We are here to talk about drivers. Are you guys excited? I'm excited. All right. So I'm Matt Stump. I'm a solutions architect with DataStax. That means I go out in the field and help you successfully deploy Cassandra. To my right, your left, is Michael Pennick. He is with the drivers team. He works on the C++ driver. So today we're going to talk about the C++ driver, the driver ecosystem in general, the Python driver, C# driver. Basically, what are they? Why would I want to use them? How to best use them, and then what's coming down the pipeline. All right? So this often confuses people. So there are many protocols, 3, I suppose that counts as many, protocols with, that you can use to speak to Cassandra. Right? They're the stream protocol. That's the one built into Cassandra is for bulk loading. But you got to understand how storage engine works, right? And so it's like I'm laying out cells, and if you get it wrong, well, too bad your data's corrupt. There's thrift, which everybody knows about, right? It's the old one. It's the original RPC mechanism for Cassandra. And then starting with Cassandra 1.2, there's the native binary protocol. And that's primarily what we're going to be talking about today. So there are thrift drivers, so if you have an older code base, these exist, right? And so when people talk about Hector and Osteonics and a bunch of others, they're talking about thrift. But seriously, do not use thrift. Do not use thrift. Seriously, not kidding. People will yell at you. You might even get laughed at. The reason why is thrift is synchronous, it's old, it's kludgy. You're never ever going to get like the high performance that you want. Like Jonathan was showing it during the keynote, you're going to get double the performance simply by switching to a DataStax driver. We've got a bunch of different supported languages, right? So Java and Python are the oldest drivers, and so they are feature parity with Cassandra 2.1. So Cassandra 2.1 came out with user-defined types, and a bunch of other stuff today, right? All of those drivers were released today with Cassandra, 100% feature parity, right? Also, the C# driver, also feature parity. The Java and Python drivers actually distributed with Cassandra. So if you're running the newest version of Cassandra, you've got the jar right there. You can just point your app at it and go. Ruby, Node.js, they are also newly supported DataStax drivers. They're in beta right now, but the release schedule is super aggressive, and you can file bugs against it, and they will get fixed. Right? There is a time when you could file an issue and nobody would really look at it. But no, we treat this as a product. This is how you interact with Cassandra. It is the most important thing outside of Cassandra proper, right? Because if I can't talk to my database, what am I doing here? So we treat this extremely seriously. So why would I use a DataStax driver? First is dedicated teams supporting you, so fixing issues, adding functionality. Dedicated QA teams. They stand up 1,000-node clusters, test it, make sure it actually works, right? If you're using one of the older thrift drivers, you don't have that guarantee, right? It's just open source. Maybe somebody will get to it. So it's cluster and schema aware. There's another big one. So I go to customer sites, and I help them deploy applications that never go down. I mean, we've got many, many customers that have 0 downtime over 3 years. That's not like with an asterisk against it, only downtime during planned events or what have you. No, 0 downtime over 3 years. And the way that you do that is you write a cluster-aware, a schema-aware client. And the only way that you can do that is by using these DataStax drivers. The DataStax driver hooks into the gossip protocol, and it gets notification that a node has joined the ring, and then automatically gets added to the connection pools. If a node leaves the ring, we also know about it, and we remove it from the connection pools. It's got policies. So one of the big ones is the data center aware policy. If you have multiple data centers, and if you're writing to one data center. You don't want traffic crossing into the other data center because that's A, costly, it's higher latency, and it's just not going to get you the behavior you want. So with the DataStax driver, you can say, well, I want all my writes to go to this local data center. And then only if this local data center goes down, then spin up and start writing to the other data centers. It's got the standard round-robin policies within the data center, but additionally, it's got token-aware policies that can be laid on top. So when I say token-aware policies, Cassandra is a giant distributed hash table, right? And so I'm going to run my primary key through a hash function, and that's going to tell me which node it lives on. Well, if the driver is cluster-aware, then I can tap into this location information. I know where my information is going to be, so I can just say, node, please give me my information, or node, please persist my information. I get to skip a hop, right? That's important when I'm shooting for these ultra-low latencies, right? So that's built in. You can take advantage of this. All the failover policies. So what happens if I have a bunch of nodes fail all at once? Say I got a bad shipment of SSDs, right? And all of a sudden I can't achieve quorum. So do I want my app to fail? I don't know. Do you want your app to fail? So instead, maybe you can say, well, if I can't achieve quorum, maybe I'm going to downgrade to a lower consistency level, right? You can ask that. There's a policy in there called the downgrading consistency policy. So you say, this is what I want, but this is what I'm willing to accept if I can't get it, right? That's an option to you. All this extremely advanced, very hard to get right policy is built into the DataStax driver. You don't have to do this, right? It's just handled for you. I can't stress that enough, right? And it's QA'd, and it just works, right? We have an extremely advanced automation suite that stands up clusters, starts firing load against it, takes down nodes, puts up nodes, changes schema, just to make sure that all this works. And they're doing it all the time across all these different operating systems. Extremely fast. It's the fastest RPC mechanism for Cassandra. So like you saw Jonathan saying during the keynote, you know, they're pushing 180,000 ops per second on a small cluster. I think that might have been per node. Yeah, that's per node. 180,000 ops per node on decent hardware, not like screaming high-end hardware, decent hardware. It's faster, like Thrift is going to top out at like 50 to 70,000 transactions per second. Because the protocol is asynchronous, you have fewer connections into the cluster. You know, and it's going to generate less garbage collection, less heap pressure. You're going to be doing fewer of these long GC pauses. All of that matters when tuning to a lower SLA. And the two last points are idiomatic. So we've gone through great effort to make it feel like the driver is native to that language. So if you're using it from Ruby, well, we're going to make it feel like a Ruby driver. If you're using C++, we're going to make it feel like any other C++ library. You know, we know that we need to come to you. You know, we're not going to force our ideology upon you. So best practices include always use quorum or local quorum. So in the Cassandra world, there's a consistency level specified with every read and write, right? There are a couple different levels. There's one, there's any, there's two. But the ones that really matter are quorum and local quorum. Quorum means I need the majority of the replicas of a piece of information to acknowledge a write. And the majority, once they acknowledge the write, only then will the write be considered durable and good, right? When I reverse that process, I do a read also using quorum. And that means that I have an overlap, at the very least, of nodes that have received the latest value and nodes performing the read for the latest value. So therefore, I'm always guaranteed to get the latest value. Does that make sense? I see a lot of sort of passive. You can yell things and throw things at me, but so local quorum is just the data center aware counterpart to it. So you're saying that I only need the nodes in my local data center to acknowledge a read or write before it's considered durable or good. Use prepared statements and cache those prepared statements. So the driver, when you execute a prepared statement, it's going to actually prepare that statement for you across all of the cluster nodes simultaneously. And only then will it return the feature as good. And then when you execute that prepared statement with a bunch of bound parameters, it gets to skip the parsing stage of the query. And so, you get to cut off like 30% of the overhead of processing a query. So it is not trivial. The DataStax drivers keep track of which key space you're currently in, right? And so one of the things that's available to you is you can say, I want the client to connect using a particular key space. And then when you execute a statement, it'll just assume that you're using the column families from that key space. The only problem with that is that it makes it difficult to do queries across multiple key spaces, and that all sessions that particular session is bound to that key space, right? So if you're using multiple key spaces, you have to stand up multiple sessions. So if you qualify your key spaces if you fully qualify your key spaces, then you don't have to do that. You just use one session across all your key spaces. Use the DC-aware and token-aware policies. This has changed in the most recent releases, where it'll use the DC-aware policies by default. But in previous releases, so if you have, let's say, version 1 of the Java DataStax driver, it would use the non-DC-aware policy. In that instance, it would automatically cross the data center. So if you had multiple data centers and you said, I want to perform round robin, it wouldn't just perform round robin within that one data center and try and send traffic across the data center. So that's a big one. That's a big performance one. The token-aware policy, as I previously mentioned, allows you to skip directly to the node that has data for you. And so you become aware of the cluster. Because of that awareness, we know that node A has this token range, and so when we need information from that token range, we just go there. And then one of the other things that I often see people do is that for batches, they'll try and create these giant batch statements of 1,000 items and to speed up throughput for requests. And that's just, it's not going to get you what you want. Batches aren't designed for that. Batches are, I'm going to create a bunch of items and I want Cassandra to take over responsibility for making sure that those items get inserted. It's not for doing big writes. For doing big, high throughput writes, it's actually faster to fire it off as individual queries. But let's say I want to push gigabytes per second, then sometimes it's better to go over to the streaming protocol. Okay. Does that make sense? Okay. Yeah.
Especially when you do the writes, doing individual writes versus doing batch writes. Of course, now, you don't want to batch thousands of writes at the same time, but if you do some batching, let's say 8 or 10, actually you do see significant jump in performance.
So 8 or 10, yeah, it can help because it's being sent as one request. But the thing is, people often take that and then they just go crazy. Literally, it's like I show up at a site and they're doing 10 batches of 10,000, and they're asking me why they're having GC issues. And meanwhile, they're trying to send through requests that are in tens or hundreds of megabytes. And what do you think was going to happen? Yeah, and so the batching is meant for batching gives you the guarantee that if one write happens, then pretty much all the writes for that batch are going to happen. Or Cassandra will make a best faith effort to make sure that they happen. The only time it won't happen is if you were to permanently lose all nodes that contained a particular replica. So, and cache contention. So, oh yeah, go.
Sorry, one question regarding the batching. Is it possible to reduce the consistency level requirement, so reduce the requirement on the Cassandra side to maintain that consistency, then increase size of the batch?
Yeah, but yes, it'll help, right? But it's not going to make things better. It's still you're passing around this giant chunk of inserts. So what happened? So let's walk through what happens when you're processing a batch, right? Because I'm creating a batch. That batch is probably going to be intended for multiple nodes because the partition keys are going to be different, right? So I'm going to take this big batch and I'm going to hand it off to a coordinator. Then that coordinator is going to have to take that batch, split it up into all of its separate mutations, and then spread it out, right? And so I'm asking the node that's acting as my coordinator to do all the work of the client for me, right? And so I'm giving it more work, and as a result, its garbage collectors are going to have to do more work. Instead, what I can do is I can just have it as individual queries and fire those off. Each one of those separate queries is going to have a different coordinator most likely, right? And then, so I'm spreading my load much more uniformly. It's the same amount of work overall, but it's spread over multiple nodes. And so you'll get much more uniform load.
Okay,
right?
thank you.
Okay. Yeah. It's sort of an advanced topic. The problem is that
Can you repeat the question, please?
Oh yeah, okay. So for batched insert, we're sort of getting behind, but for batched inserts, there is a streaming protocol. It's the same protocol that Cassandra uses when it's transferring large amounts of information around, but it works on SS tables, not logical rows. And so you have to be able to write entire SS table. Does that make sense? All right. Oh, it doesn't? Yeah, so that's the problem is so batch with token aware, it doesn't. No, it can't.
Just find some coordinator.
Yeah, it'll take a coordinator and it'll just send over the batch, and that coordinator will take over responsibility. Because the problem, like most batches are across multiple partitions, so which one would you send it to? So I'm going to turn it over to Mike, and he's going to talk about the C++ driver. Oh, okay.
Oh, hi. Me and Matt and I are the primary authors of the C++ driver, and you're probably wondering why this says C and C++. Like, if C developers and C++ developers alone will roll their eyes at that. Well, this actually kind of makes sense here because the API itself is pure C, and the implementation is C++ because it's a little complex inside. So the C++ driver has a little broader set of goals than the other drivers because one of the primary goals was to make it easy to wrap. And that's a lot of languages offer a foreign function interface, and usually that interface is through C. So we made it ANSI C. We use simple POD types and very few structures and opaque pointers, and that makes it an awesome to wrap in other languages, PHP, Go. Another goal we had was to make it very high performance. We don't want the driver to be your bottleneck. We want Cassandra to be your bottleneck. We don't want to be in your way. Another goal that's kind of a little bit longer term is that we want to have feature parity, so with the other drivers. So we're a little bit behind now, but we're going to catch up fast. And then we also want to be compliant with the newer versions of Cassandra as they come out. So I talked about making it easy to wrap. Another one of the features that we have internally is the architecture. So a lot of languages, say PHP for example, don't have great multi-threading support. So it's not like you can lock and everything. So if you want to implement one of the policies, like a load balancing policy or reconnection policy, in other drivers like the Java driver, it becomes a bit more sophisticated. You have to use lockless primitives like memory fences or locks or that kind of thing. You might not have that in those languages. So what we do is we serialize in the session thread, And this has all of the state that you would need to implement one of those policies, and it would be executed there. Another thing we do to kind of performance is we have minimal copies. So if you send a megabyte chunk, we're not copying that a bunch of times. We just send that to the socket. So what does this API look like? Right now we support 1.2 and 2.0. Also, it's completely asynchronous. So we don't even have a synchronous API. It's really simple to implement yourself. Basically, you just wait on the future, and you have a synchronous API. And then all of the objects that you would want to be set thread safe are actually thread safe. So like a session, you can execute multiple queries on it from multiple threads, and it's gonna work for you. And then the other thing we do is in the API itself, we mark types as like a result set as a const. So it's immutable, and you can iterate over it from multiple threads and have no issue. So getting started, you're going to need to install a couple dependencies, and we have very few dependencies, and that was another goal. So libuv and OpenSSL, and if you want to test and become a developer, you're going to need to install Boost and libssh2 to run tests. So to get started, you're going to include Cassandra.h, you're going to link against Cassandra, libcassandra, and you're ready to go. So let's dig into what this API looks like a little bit. So the first thing you need to do is actually connect. So that's the whole connection path there. So to dig into it a little bit, you're going to create a cluster object. And the only thing that you're actually required to do is to give it some contact points. You need to show it where your cluster is. So you can even just include one IP if you want. And then it'll auto-discover the rest of your cluster. And then you'll create a session, you'll connect, and you'll get a future back. And then you'll wait on that future, and then you can check the error result as I'm doing here. And then you'll pull the session out. So once you're done with that, you've run all your queries or your application's shutting down, you actually need to close that session. So you'll destroy all the connections, you'll finish up queries that you previously queued, and that's the way you do it. And even the cool thing is, even close is asynchronous, so you don't even have to wait on that. So we don't want your application waiting for anything. So now that you have a connection, you're going to run some queries. So say you need to create schema. So I'm using this execute method, which I'll dig into a little bit. You'll create a statement. You'll take that statement. So in this example, I just provided 0, so this isn't going to take any params, as you can see in the schema. You're going to execute it, and then in this example, I didn't even wait on the future. So I just went right to the get. I'm going to check to see if there's an error. And that'll do the same thing as wait. It just kind of like coalesces those two functions together. Check the error, and then you can just free that future whenever you're done with it. So now you have a schema loaded, and you want to insert. So in this case, we're going to use prepared statements because that's a best practice. You want to definitely use prepared statements for multiple reasons. So that function looks like this. So you take your query, you're going to do the same thing as before. You build a statement again. So it's the statement, but it's a prepared statement. So it'll go off to the cluster and then send you back an ID, and you can wait on that future. And then what you want to do, actually had a previous version of this where it returned the prepared, as you can see, and then I use it for subsequent queries. So you can just use that object, and that object is thread safe. You can use it however you want. Just keep it around. So now that you have inserted data, so you have your data in there, how do you get it back out? So you're going to run a select, and it's kind of the same setup as the other ones. I create my query, but the difference here is I have, instead of waiting on that future or calling any get method on there and actually stopping the application, I'm going to set a callback on there. So my application can set that callback and immediately return, and then I can go on to doing other things. And then when that completes, it'll come back and call me, and that's the lowest latency way to handle async requests. So what does that onSelect attendees method look like? So now we're going to start messing with data. How do we handle a result set? So you're going to get that future back inside of that callback, and then you're going to get a result set from it. And from there, you can create an iterator on it. You can there's another just a handy method to get the first row, because that's oftentimes what you just want. You don't even, you had a count on a table or something like that. You just want the first column, or the first row. And you can dig through there. So I'm iterating through. I pull out values, and values are kind of like variadic types, because we have a bunch of different types in Cassandra. and then you use a more specific method to get that type out. So Matt kind of went over this. We're very, very aggressive on our timelines. As you can see from this, you might not be able to see that actually, but we're on a monthly cadence right now of releasing betas, and we're releasing pretty major features in each one of these. So, and then each beta, we're fixing bugs that we get in there, and more critical bugs get pushed right onto the master. So a lot of great releases. So the cool thing is we have a new release out today, and in that release, we have node discovery. So it's where you set one or fewer nodes on the contact points, and you get back, it basically auto-discovers your cluster. And then the other part of it is we can also handle status and topology changes. So if you add or remove nodes, we'll get an update in the driver, and we'll respond to that and add that to the list, so your next queries will be run on those. We also ran the DC aware policy, which Matt went over the benefits of using that. Definitely want to use that. And then we also, because it's Cassandra's super distributed system, schemas are, so when you update a schema, it might, and it's just updated on that local node, and then it's propagated out. Now we wait on that. So if you alter a table, we wait for that statement to propagate across the cluster before returning to you. So you know your next queries will actually be run on the correct schema. So we have to come up with feature parity, and also support, or we're going to be supporting, future versions of 2.0. So definitely, these aren't beta 5 features. This is, and there's no timeline here. That's my disclaimer. These are just stuff we plan to tackle in the future. So I'm going to turn it back to Matt, and he's going to go over GoDriver he made.
So just to prove how easy this is to wrap, actually I'm using 2 microphones.
Oh, yeah. Sorry about that.
So to prove how easy it was to wrap, we created a GoDriver in like 4 hours. And that was me mostly screwing around and learning how to write GoDrivers. So idiomatic, so I'm just going to create a new cluster, and I'm going to connect using that cluster, wait for it to connect. I'm going to execute a statement and get some stuff back. Let's go ahead and do that. Oops. Boom, pull the cluster. It's, wow. All right. So I'm just iterating through all the cluster names. So it's not a very exciting demo, but the more exciting thing is that it's all done in 335 lines ago. So 335 lines ago, I've taken the C++ driver, and I've added functionality for a new language. It's that easy. Nobody's excited. But anyway, yeah. So it's released today. It's under my GitHub profile.
Does anybody have any questions?
Okay. So it's there. Go get it. And then resources, right? And then also, there soon to be coming out is going to be the Scala driver, and PHP is also on the roadmap. So those are coming soon.